Hello, everyone. I am Amber A.G. DeHart, and I am so sorry I wasn't able to join you this week via a live Zoom call, but I did want to answer some of your questions that you submitted and be able to show you what the cube is. So here's the size of the cube. It is approximately 4 by 4 by 4 centimeters, but it's not actually a cube. If you look at it, you will notice that it does taper as you go towards the bottom. Now, your educators have information on the specific dimensions of the cube and the different sides and the length, and they have this material in the curriculum. So they can give you those dimensions for you to be able to prototype the cube. And so now I am going to answer your questions. I'm going to be looking here from time to time because I have your questions on another screen. So the first question that we have is, will the product sent in the cube be exposed to outer space, or will it be locked up? Good question. For the sounding rocket, the experiments are inside a large canister that is inside the aluminum nose cone, so they will be fully in the dark and protected. The pressure will not change. The temperature, the information regarding the specific temperatures are found in the curriculum, but it can get about as high as 35 Celsius, but that's upon reentry and maybe for an hour or two. Do not use high temperature or low temperature as your independent variable for experiments for the sounding rocket. Now, in the balloon, these are exposed to the near space environment for anywhere from 5 to 10 hours. What is separating these cubes from near space is another layer of clear plastic that is very much like the plastic of these. So the experiments in the balloon will be exposed to high radiation, so all forms of the electromagnetic spectrum, low temperatures down to negative 65 C, high temperatures up to 55 Celsius, and very, very low air pressure, 1/100th that of pressure of sea level. So 1/100th in atmosphere, and also very, very low air humidity. So almost no moisture in the air at all. The second question is, my experiment involves a compass. The presence of a magnet nearby will affect my reading. Yes, it will. So when you are sending your experiments and the information that comes to us, it will need to include a reminder to us closer to the date of where we integrate into whether it's the sounding rocket or the balloon. You need to let us know in a reminder that there's a compass in there so that we keep it away from any other experiments that contain magnets. But I really don't have any experiments this year with magnets, which is a good thing because we get so many of those that it's hard for a magnet experiment to stand out. How long will it take to reach the destination, and what is the temperature of the place where the cubes will be placed? I'm thinking you're talking about transport, and so it can take a couple weeks to express ship. So with FedEx or DHL, it can take a couple weeks to get to us, and the experiments will stay stored with us for a couple of weeks if it is for the sounding rocket, and it could be a couple of months for the balloon. We store them in locations where it's average air temperature. So it's climate controlled, it is away from direct sunlight. And so we make sure that the temperatures and the humidity is not fluctuating for that. The fourth question is, will the cubes be classified as per the experiment or school-wise? It will be classified by the experiment itself. So the way we identify the individual experiments is that there is an experiment number that you'll see, and also each experiment has its own individual title. So here are some questions regarding the name of the experiment. So some questions here. To see the effect of space temperature on the hydrogen gas, we need a bit more information. So when you are drafting your titles of your experiment, please ask your educators to refer to the application for spaceflight guide that is in the online course that they have received. That should appear in Module 5, Application for Spaceflight Guide. There are 12 pages that walk you through everything that's expected as far as the title, how to identify variables, how to write your hypothesis. And we're looking for an experiment that connects to a real world Earth or space-based problem or need. So my question to you is, why do you want to see the temperature change on hydrogen? Why does that matter? What is it connected to? How is that going to help people in space or space exploration technology or something here on Earth? So keep that in mind. And the names of the experiments will be something like the effect of changing temperatures on the degree of expansion of a styrofoam ball. Don't use that because I just made that up. But what I'm looking for is you're showing the relationship between the entity itself. So what you're sending up, which in that case would be the styrofoam ball, you're looking at what the independent variable would be, which would be temperature in that situation or low air pressure. And then the dependent variable is the degree of expansion. So again, make sure educators and students, you're looking at that application for spaceflight guide to see how to structure your titles and to create your hypotheses. Okay, see what else there is. So we also have, has the conductivity of any of the materials changed? Are questions, which material has the most changes in conductivity? Which material has the most changes in strength? Okay, so all of these questions, such as, do any of the materials have cracks or fissures? Does an insulating material like ceramic become more conductive or more insulative? These are things you need to research. So these are not answers that your educators are going to provide to you or us. The point of this is for you to pose those questions, to have that level of inquiry, and then your educators can help guide you to find those answers and that research. Another name of an experiment: to check the effect of radiation and low temperature on pure honey. Wonderful. Okay. So what aspect of the honey is going to change? Are you looking at viscosity? Are you looking at the antibiotic properties of honey? What is it that you're trying to see happen or change in the honey? That needs to go in the title of your experiment and also in your hypothesis. Another question is, which cubes in space experiment has been converted into real life experience and which age group did it? Well, the one that is in the news in the past couple of weeks has been in students in Ottawa, Canada, and Ontario. They were students between the ages of 10 and 12, and they looked to see if the cosmic radiation that an EpiPen solution, so an EpiPen is, oh my goodness, epinephrine, I was trying to say methamphetamine and that wasn't right. So epinephrine, does the concentration of epinephrine change when it's exposed to cosmic radiation? And the students were trying to determine if EpiPens could still be used in space if they were exposed to radiation. Epinephrine is used to help combat anaphylactic reaction, an allergic reaction, can also be used to stimulate the heart if someone was having a heart attack, and also can be used as a coagulant during surgery. So if there needed to be hand surgery, the hand would be coated in epinephrine so that it wouldn't bleed. That's important in microgravity because you wouldn't want blood going everywhere. That is something that has gotten a lot of attention in the past 2 weeks and does have real world applications. Something also more simple is we had a student that sent up all types of different files on an SD card, just off the shelf, commercial off the shelf, which is COTS. That's what NASA uses. Can you use commercial off the shelf storage devices in environments where they get exposed to high radiation? And will those files be corrupted? That's really important for NASA to know, because if they can use off the shelf materials like storage devices and don't have to have something specially designed for it, well, then that saves NASA a lot of money. And let's see, I think that is it for the questions that I have received. So here's the thing to remember, and also make sure that your educators show you the pages for the requirements and constraints for each of the missions. So the sounding rocket and the balloon. For the rocket, a big difference is that we cannot fly any kind of batteries, even button cell batteries. We can't fly because there can't be any free-flowing current in anything in the rocket while the rocket is being armed. Now, there are electronic payloads in the big payload bay, but they have what's called a G switch attached to them. And this is far more electrical engineering than we have access to or that we can pay for. But they have what's called a G switch, so that when the rocket launches, the pressure of the G forces pushing down on the switch opens up to allow current to flow. So there's an actual interrupter to the free flowing current. And when the G switch activates, it closes so that then the current can flow. There's also no liquids. And you do need to be mindful of what you can and can't import and export through your country. So you need to check your immigration and customs website to see what materials are prohibited from shipping out of your country or bringing back in. Seeds are a big aspect that can be prohibited as well. And also any type of coins. For the rocket, for this, whatever is put in here, well, this has to equal 64 grams plus or minus 2 grams. So if you put something like a storage device in here that may weigh only, let's say, 10 grams, and the mass of the cube is about 10 grams, then you need to find at least 40 other grams of mass to put in here as ballast. That's really important, because every cube has a requirement of being 64 grams plus or minus 2 cubes. The balloon mission does not have that constraint on the mass of the cube. So, and you can also put powered experiments in the balloon. So I hope that helps you. I'm very, very excited that you have joined our program this year. Your school first participated in 2014 and 15. We are so excited to have you back with us this year, and we are looking forward to hopefully flying your experiments. So from the Cubes in Space office, take care. Bye-bye.